In this video we have a couple of rational equations that we're going to solve, and we're also going to check for extraneous solutions at the end. So in this first problem, on the left side of the equal sign, you see that we have some subtraction. So we have to handle that first. And because we have common denominators, it makes it a little bit easier because we could just deal with the numerators. We could take 1 and then subtract 18x plus 10 from it. So there we go. We've got 1 minus, and then this binomial in parentheses. And I kept it in parentheses just to show that we have to subtract both of them. We're not just taking away 18x. A common mistake is sometimes that I see is we'll have a 1 and then someone will write minus 18x and then they'll just have that plus 10 at the end. This is going to give us a wrong answer. We have to take that subtraction sign and subtract 18x, and we also have to subtract 10. We also keep that 9x squared down in the bottom because think of if you had, let's say, 5/6 and you subtract 1/6 from that. Well, that's going to give us 4/6. We don't actually subtract the denominators at all. We keep that the same, so we're going to keep this 9x squared the same here. In my next step, I'm going to actually take away these terms. So I'm going to have 1 minus 18x and then minus the 10, and I'm going to rewrite everything else. Now I'm going to combine like terms, so I have 1 minus 10, that's going to give us a negative 9 or minus 9, and then minus 18x, and then again I'm going to rewrite everything else. Okay, now in this part we have to get rid of the denominators. So to get rid of a denominator, I need something on top that looks just like it. So on this right side I'm going to multiply it by an x squared because an x squared over x squared is just 1, so that cancels out. Well then, to keep everything balanced, I also have to multiply the left side by that same thing. But that's kind of nice because we have an x squared on top and an x squared on bottom, so that actually cancels out. Now, everything's gone from our denominators except this 9. So now I multiply this top part by 9 so that that cancels out with the bottom part. But again, to keep things balanced, I multiply the right side by a 9 as well. Now I have everything out of the denominator except the invisible ones, I guess, technically. But in the numerator on this left side, I have a minus 9 minus 18x, or a negative 9 minus 18x equals 1. And I can continue solving from there. I'm going to add 9 to this left side to cancel it out. Add it over to the right side as well. I'm left with negative 18x equaling 10. Now I'm going to divide this left side by a negative 18 to cancel that out. Divide this by a negative 18. And I'm going to be left with an x equaling, this will reduce to be 5 over 9. And it's a negative 5 over 9. Now the last thing that we need to do is check to see if this is an extraneous solution or not. And what that means is it's going to be a solution that doesn't make sense. So if we plug in a negative 5 over 9 back into the denominator, I do not get a 0 at all. I'll get a number. And that's okay. So this is going to be our final answer. If you're thinking about it like that and just don't understand what I just said, let's say if you had an equation, maybe, and I'm just making this up, but maybe on one side of the equal sign you have a 2 over x minus 3. And let's say that our answer ended up being x equals 3. Well, if we plug a 3 into that x in the denominator, I'm going to have 2 over 3 minus 3. That would reduce to be 2 over 0. And we cannot divide by a 0, so we would say that this x equals 3 is an extraneous solution because, yeah, we solved the equation and we got x to be 3, but once you plug it back in, it doesn't make sense because we can't have a 0 in the denominator. So that's an extraneous solution. On to the second problem, and this second problem is really similar to the first one because we have to deal with the subtraction again. We also have common denominators, so that's going to make things a little bit easier. So let's go ahead and do the subtraction in the numerator. I'm going to have an x squared minus 18x plus 80, and we're subtracting 1, and I'm going to rewrite everything else. Okay, the next step, I'm going to actually do the subtraction. So that means I'm going to be left with an x squared minus 18x, and then 80 minus 1 is going to be 79. And then I'm going to rewrite everything else. Now at this point we want to get rid of all the denominators. So on the right side I want to get rid of the x squared, so I multiply it. X squared over x squared goes away. I have to multiply the left side by an x squared as well to keep everything balanced. And this is nice too because we have that x squared canceling with this x squared. And just like our last problem. Now we also have to get rid of the 7. So I multiply the left side by 7. 7 over 7 goes away. I have to multiply the right side by 7 as well. And now on this left side I'm left with my trinomial x squared minus 18x plus 79. On this right side I'm left with 1 times 7, which is just 7. Now there's no way that we can combine x squared minus 18x. They're just not like terms, so we're going to have to factor this. And to be able to factor, we have to set our equation equal to 0. So now I have to get rid of this 7 on the right side so that we could get a 0. It means I have to subtract 7 from this left side as well. Now I'm going to have an x squared minus 18x plus 72 equals 0. And now I have to come up with all different types of factors that multiply together to get a 72 but add together to get a negative 18. And the two numbers that we're going to use is x minus 6 and then x minus 12. That's going to be set equal to 0. So I should say the numbers are negative 6 and negative 12. That's what I'm going to use because negative 6, negative 12 multiply together to give us 72, and they also add together to give us negative 18. Now I can set both equal to 0 and solve. So I need to add 6 here and add 6 there. That cancels out. I'm left with x equaling 6, and then I'm going to add 12 to this left side. That cancels out. I have to add 12 to the right side, and I'm finally left with an x equals 12. So these are going to be my two answers, and if I plug them back into my variables in the denominator, I'm not going to get a 0 at all. So neither of them are extraneous solutions. They're my final answers.